Arithmetic sequences are sequences in which each consecutive term either goes up or down by the same value. That means that you either add or subtract the same number to get each consecutive term. This formula, a sub n is equal to a sub 1 plus n minus 1 times d, is the definition of an arithmetic sequence, where a sub n represents the nth term, a sub 1 represents the first term in the sequence, n is the term, so if you're looking for the 100th term, n is 100. D is called the common difference. So if the numbers are going up, the common difference is positive. But if the numbers are going down, the common difference is going to be negative. So let's find the nth term of the arithmetic sequence 258 ... So in this formula, I know what a sub 1 is. That's the first term. It's 2. I don't know what n is because I'm writing a general formula for the nth term. But the common difference is 3, because each consecutive term is going up by 3. Now you can leave the equation like this, but it looks much nicer if you distribute it and you combine like terms. So a sub n equals 3n minus 1 is a much nicer looking equation to represent the nth term of this particular sequence. So now if I wanted to find the 50th term, I could just plug in 50 for n. And 3 times 50 is 150, minus 1 is 149. So 149 would be the 50th term of this sequence. Let's find the first 6 terms and the 300th term of the arithmetic sequence 13, 7, ... So I know the first 2 terms. In order to keep finding through the 6th term, I would have to determine the common difference. Well, the common difference is pretty easy. It's minus 6. So that means the 3rd term would be 1. The 4th term would be negative 5. The 5th term would be negative 11. And the 6th term would be negative 17. I just keep subtracting 6 each time. Now I want to find the 300th term. So the 300th term is going to be the first term plus n minus 1 times the common difference. And then all you have to do is plug this into your calculator, hit enter, and you're going to find out that the 300th term is negative 1,781. The 11th term of an arithmetic sequence is 52, and the 19th term is 92. Find the 1,000th term. Well, in order to find the 1,000th term, it'd be great if I knew what the first term of the sequence was and the common difference. Right now, I don't know that. I just know that the 11th term is 52. Well, I can plug that into the formula because I know the nth term is 52 and I know n is 11. And I also know that the 19th term is 92, so n must be 19. What I have here is a system of equations. The 2 equations that I have are a sub 1 plus 10d equals 52, and the second equation is a sub 1 plus 18d equals 92. Now when we solved systems of equations, we had 4 different ways of doing it. The first method was graphing. You could solve both of these equations for d, pretend like they're y, plug them into the graphing calculator, find the point of intersection. But you'd have to play around with the calculator a little bit to figure out where the intersection is. The second method we learned was called substitution. I'm going to honestly tell you, I never use substitution to solve systems of equations. I do use substitution when I do calculus, but not for this. The third method, and the one you probably like the best from Algebra 1, was called elimination. That's the one where you multiply one of the equations by a number, so that when you add them together, one of the variables goes away. And then it makes solving the problem relatively easy. If I multiply the first equation by negative 1, a sub 1's cancel. I add them together, I get 8d is equal to 40, so d must be 5. So each consecutive term is going up by 5. To find the first term, all I have to do is plug d back into one of the two original equations, and then solve for a sub 1. I'm going to find out that a sub 1 is 2, because I'm skipping ahead. 50 is equal to 52, so a sub 1 is equal to 50, or is equal to 2. Now that you know the first term and the common difference, now we can go and find the 1000th term. Now the fourth method that you could have used was using a matrix. I will show that in class, but I'm not going to show it on the video because it doesn't work as well as it does when I actually display it in class. So for the purposes of this problem, I'm just going to use elimination. So now I know the first term, I know n is 1000, I know the common difference. All I'm going to do is plug that into my calculator, and I'm going to find out that the 1000th term is 4,997. Just like in the previous section where we were finding partial sums, we can find partial sums of an arithmetic sequence. For example, if I wanted to find the sum of the first 50 terms in a sequence. Well, I don't want to type 50 terms into my calculator to find out their sum. So there must be an abbreviated way of doing this. We have these two formulas that are actually the exact same formula in two different formats, depending on which information you have. The first one says that the sum of the first n terms is equal to n divided by 2, 2 times the first term plus n minus 1 times d. That's if you know the first term, the common difference, and you know the number of terms you're adding. Sometimes, though, you actually know the nth term. In that case, you can find the sum of the first n terms by doing n divided by 2 times the first term plus the nth term. Let's actually try this formula out on one of the problems. Find the sum of the first 40 terms of the arithmetic sequence 3, 7, 11, 15, ... Well, there's two ways I can go about doing this problem. The most direct way is that I know the first term is 3. I know the common difference is 4. And I know I want to add the first 40 terms. So I can use the first formula, n over 2, 2 times a sub 1, plus n minus 1 times d, to find out what the sum of the first 40 terms is. So when I plug this into my calculator and then multiply it by 20, I'm going to find out that the sum of the first 40 terms is 3,240. Now this isn't the only way I could have done it. I could have first found the 40th term by doing the first term plus n minus 1 times d, and I would have found out it was 158. And then I could have used this formula where I know the first term and the nth term, and I would have gotten the exact same answer. But notice that the second method actually took more work, and I like to do things in the quickest way possible. Let's find the sum of the first 50 odd integers. Well, let's start with, what are the first 50 odd integers? Well, they are 1, 3, 5, 7, 9, ... So the first term is a sub 1, and the common difference is 2. So to find the sum of the first 50 terms, I can just do n divided by 2, 2 times a sub 1, plus n minus 1 times d. Pretty easy. All I have to do is shove it in my calculator and then multiply what's inside the brackets by 25, and I'm going to find out the answer is 2,500. Or I could have first found the 50th term by doing a sub 1 plus n minus 1 times d, and I would have found out the 50th term is 99. Then I could have shoved it back into the other formula, n divided by 2, a sub 1 plus a sub n, and I'd end up with the exact same answer. An amphitheater has 50 rows and 30 seats in the first row, 32 in the second, 34 in the third, and so on. Find the total number of seats. Well, we want to find the sum of the first 50 rows. So I know n is 50. I know the first row has 30 seats. Again, n is 50. The common difference here is going to be 2 because each consecutive row goes up by 2 seats. Again, this is really nice because now all you have to do is plug in your calculator and multiply it by 25. And you're going to find out that it's 3,950 seats. But again, you could have first found out how many seats were in the 50th row by doing, not 2, a sub 1 plus n minus 1 d. And you would have found out that there are 128 seats. And then you could have found the sum of the first 50 rows by doing 50 divided by 2, a sub 1 plus a sub n. And you would have ended up with the exact same answer. How many terms of the arithmetic sequence 579 must be added to get 572? The first thing you need to do in this particular problem is determine what they're asking you to find. They want to know how many terms. That means n. What's n? If you want to add all these numbers together and get 572, so this is s sub n. So 572 must equal n over 2. 2 times the first term I know is 5, plus n minus 1 times the common difference is 2, because each consecutive term is going up by 2. You have an equation here with one unknown, and that one unknown is n. So we're going to have to solve this algebra equation, but the first thing we're going to have to do is a little bit of simplifying. So I'm going to simplify what's inside the brackets here. I get 10 plus 2n minus 2, so that's 8 plus 2n. Next, I'm going to distribute the n over 2. So I get 572 is equal to 4n plus n squared. Oh, I know this equation. This is a quadratic equation. And in order to solve a quadratic equation, it needs to equal 0. One way of solving this quadratic equation is to graph it and to find on the table what values of x give you a y value of 0, or you could try to figure out where they cross the x-axis, but you won't see it on the screen without playing with the screen. You could factor it. You could use the quadratic formula. I'm actually going to show you what it is in factored form. It would take quite a while to really figure this out, but this is what it is in factored form. N minus 22, n plus 26. And then you use the zero product property to solve for n. Well, here's the thing. N is the number of terms. You can't have a negative number of terms. The number of terms n will always be positive, and it will always be an integer. So the only possible solution would be 22. So you would have to add 22 terms together in order to get a sum of 572.